Spacecraft traveling to Jupiter from Earth would most likely have to navigate through or around which natural obstacle? Looking at the picture below, this is going to do a good job explaining the actual question itself. First part, this is the sun, the center of our solar system. Everything in our solar system is going to revolve or travel around the sun. The first inner planets, our first four inner planets, we have Mercury, followed by Venus, followed by Earth. We are the third planet from the sun, followed by Mars. These are the four inner or rocky planets. Outside of our four inner or rocky planets, also known as terrestrial planets, is our asteroid belt. It is theorized that the asteroid belt could have potentially been a fifth planet if these rocky bodies or asteroids would have condensed or coalesced down to themselves. Outside of our terrestrial planets is our asteroid belt. Outside of the asteroid belt are our gas giants or Jovian planets. In the question, it asks Uranus and Neptune. These are both gas giants that are much further away. Jupiter is the fifth planet from the sun. Asteroid belt is the best answer, and a comet's tail does not even address the question whatsoever. So the best answer, once again, is C, asteroid. A star begins its formation as gravitational forces cause instability within. Is it a black hole? A black hole is the end of a super large or super giant star. So this would be coming after a supernova, so not the correct answer. This is an explosion. A red giant. This down here represents what a red giant is. Our star in its stable state on the main sequence is going to eventually turn into a red giant as the red giant is trying to stay alive. Unfortunately, eventually all stars will die. A supernova, this is what occurs. A super large star is going to continue to try to force itself to stay alive, and eventually it's going to explode. Upon that explosion of a very large star, you're left with basically two options. It's a black hole or a neutron star. Again, the black hole we talked about up here, this is the end of a life cycle of a star. Again, end of a life cycle or nearing the end of a life cycle, nearing the end of a life cycle. And then we're talking about a nebula or a stellar nebula. A nebula or stellar nebula is gas and dust, and that gas and dust is basically pushed together because of gravity, and over time, friction and force and pressure is going to help heat that gas that was very, very cold to something that is able to fuse, make hydrogen and hydrogen slam together to create helium. This, again, nebula is going to be the answer here. A black hole, red giant, and supernova are all end life cycles of a star. Starting with the event that scientists theorize happened first and ending with the event that scientists theorize happened last. Arrange the events in chronological order. These are test questions that are called technology enhanced test questions, and this is where you're supposed to drag and drop. Unfortunately, I don't have that ability, so we're just going to talk about the question. This picture down here talks about the Big Bang as it started, and over time, things started to form. So it's asking you which event happened first and all the way down to last. So the Big Bang definitely was the first item that caused our history. Essentially, there is one single point called singularity that, according to the theory, simply exploded, and everything now is what it is. After that, you're left with birth of earliest stars, formation of the sun, or origin of life on the Earth. The Earth can obviously not occur until after formation of our sun, but the sun was not the earliest star because other stars have already died. So that means the birth of the earliest stars comes next, followed by the formation of our sun, and the origin of Earth is the last part. In the scale of things, we are very, very young compared to everything else that has occurred. Which characteristics do all the planets in our solar system have in common? Is it A, angle of axial tilt? Axial tilt simply means the tilt on its angle, and our tilt for the Earth is 23.5 degrees. That is not the same for all of them. Direction of a revolution, that is how we orbit or go around the sun. Let's talk about that one in another minute. Percentages of atmospheric gases. Not all planets are going to have this same type of atmospheric gases, and some planets do not even have an atmosphere. And D, features of a rocky crust. As we talked about before, our inner planets, these are the only four that have a rocky crust. In between the fourth planet, which is Mars, and our fifth planet, which is Jupiter, we have an asteroid belt in between. These planets out here, Jupiter, Saturn, Uranus, and Neptune, are all gaseous. And we have our little planetoid dwarf planet Pluto, which is not a planet, but it does have a rocky crust. Now, let's go back to the direction of revolution. All planets are going to orbit or revolve the sun in the same rotation, in the same orbit or the same revolution, the same direction. So the best answer here is B. Why does a comet's tail point away from the sun? Is it A, the solar wind blows the tail away from the sun? If we look at this picture, and we also look at this picture, it appears as though both tails, the ion and the dust tail, are both pointing away from the direction of the sun, no matter where the comet actually is. So that sounds like a decent answer, but you can never pick the first answer that you read. You got to read all of them. It is being pulled by a nearby black hole. There is absolutely nothing in here that talks about a black hole. Just because the answer sounds interesting doesn't mean we should pick it. The moon's light only shines on part of the comet. Again, there's nothing in this statement or picture that talks about the moon whatsoever. And the comet's tail is following the path of Jupiter. Once again, there is nothing in this question whatsoever about Jupiter, a black hole, or the moon. So the only feasible and right answer here that could make any sense based on what we're given is A, the solar wind blows the tail away from the sun. Which of these best describes the composition of a nebula such as a Crab nebula? So composition basically just represents what it's made of. So Crab nebula, any nebula, is made up of basically gas and dust. So let's look at the different questions here. Large asteroids. Well, that's rocky, so it's going to be highly dense, and that's not going to be the answer here. Clouds of gas and dust. Well, nebula, or all nebula, stellar nebulas, are made of clouds of gas and dust, which when pressure is enough or large enough, fusion can occur, which is where stars form. Ice crystals. I'm not exactly sure how this pertains in this case, or planets and moons. Again, there are no planets and moons currently at this point. A nebula is made up of gas and dust. Which of these planets travels around the sun in less time than it takes Earth to complete one revolution? Again, a revolution represents the amount of time that it takes to orbit the sun. So, just as in a racetrack, if you're in lane 1, lane 2, lane 3, and lane 4, the further you are away from the center, the longer it's going to take. So Mars, which is our fourth planet from the sun, versus Saturn, which is further out, it's a gas giant, Mercury, which is our closest planet to the sun, or Uranus, which is a gas giant and further out away from this picture. It's asking which one takes the less time to complete one rotation. It has to be the planet that is closest to the Earth. Which of these measurements allow scientists to compare the brightness of stars? A, absolute magnitude. The magnitude here represents, there's two different types, absolute or apparent. Apparent represents based off of the visual, where the observer is located, or the absolute is what it actually is. So this will allow scientists to compare the brightness of all stars. Let's continue reading through, though. As we've said before, you never pick the first answer. B, critical density. Critical density is basically the amount of mass and in the given volume of our universe. So this talks much more deeply about what type of universe we're in. Is it an open, closed, or a flat universe based off of the amount of critical density or density in the universe. Orbital velocity, just how fast something is going to spin, and redshift. This is going to represent the Doppler effect. Redshift, if it's moving away from you, red away, versus blue shift, which is going to be blue towards you. Edwin Hubble, many years ago, discovered this, that the universe was actually expanding because various galaxies and stars around us were actually showing redshift when he looked through a spectrograph. Again, the best answer here is going to be absolute magnitude. In addition to Earth's orbit, which planet's orbit are shown in this picture up here? Now, if we know which planet we are, which is Earth, we are the third planet from the sun. So inside of us, let's look to see which ones they could be. Would it be Mars and Jupiter? We have 4 planets, If you look over here that are in the inner planets, you have Mercury, Venus, Earth, and Mars. So this planet here we know should be Mars. So let's look through. Okay, Mars is in the first one, but it is not Mars and Jupiter. Jupiter and Saturn, these are gas giants that are not close. Venus and Mars, as we talked about before, Venus is the second planet from the Sun, Earth is the third, and then we have Mars, which is the fourth planet from the Sun, or it's Mercury and Venus, but then there would have to be another one right here for it to be Mercury and Venus. The best answer here is Venus. And which layer of the Sun is seen during a total solar eclipse? A solar eclipse, or any eclipse for that matter, is when something is blocked out. And in this case, a solar eclipse is when the moon is going to block out the sun. Does not happen very often and not in many locations. But if we have something over top of the entirety of the sun so that it goes dark during that time frame, would it be the core, which is the center? We're definitely not going to be able to see that if something is blocking it out. Is it going to be the corona? That's the outermost gas out here. That looks to be like a decent answer. Would it be the photosphere? This is the apparent surface of the sun. I say apparent because it's a gas, so there is no true surface of the sun. It's just what we see if you can safely look through a telescope at the sunspots. Or is it the chromosphere? Which layer of the sun is seen during a total solar eclipse? This is kind of actually a trick question because during a solar eclipse, you can actually see the corona and part of the chromosphere. But in this case, the best answer has to be the corona because you're going to see more of it. Which planet has the shortest day? Day and night is caused by a rotation. So the amount of time that it takes for a period of rotation represents 1 day. A lot of times kids get confused when we talk about day and night. For a rotation, they also think about revolution. Revolution is the amount of time that it takes a planet to go around the sun once. So essentially 1 year versus 1 day. And all you have to do on this chart is simply look down and understand that rotation represents day and see which one is the smallest amount. It's not 59 days. It's not 249 days. Jupiter is 9 hours and 48 minutes to make one complete rotation, and Saturn is 10 hours, and obviously 9 hours is shorter than 10 hours. So the best answer here is Jupiter, H. Gas and dust in interstellar nebula can form. So a nebula, as we talked about before, is basically gas and dust. And over time, that gas and dust, if everything goes correctly in this extremely cool, almost absolute 0 degrees gas and dust, starts to spin and contracts upon itself, and over time, a star can form. And along with the star, also planets or a little solar system can form. So let's look down here. Stars seems to be a pretty good answer, but let's keep looking through. Comets are not going to form from gas and dust, neither are meteors and asteroids. All three of these, the comets, meteors, and asteroids, are all basically the same types of things. Small rocky bodies. A comet is basically a dirty snowball. Meteors are basically just rocks, just a little bit smaller than asteroids. I say just rocks, they're really large objects. So the best answer here is star. Which of the following best describes Earth's orbital position in our solar system? Is it A, outside of 3 smaller planets? So again, let's look at this picture over here and look at Mercury, which is our first planet, Venus, Earth, and Mars. You have your 4 planets that are your terrestrial or rocky bodied, and this answer here, A, outside of the 3 smaller planets, would represent that it would have to be in Mars's location. It is not. Is it outside of the gas giants? No. All of your gas giants are further away. Is it an outer planet? It is not one of these outer planets further away. Is it an inner planet? Yes, it's one of these inner planets, one of the inner terrestrial planets that is closer to the sun. Again, the 3rd planet from the sun. Best answer here is D. The numerous rocks orbiting the sun between Jupiter and Mars are, is it F, comets? Comets are going to have a very elliptical orbit, meaning very stretched out, and they're going to be much further away. So they're not in this location here in the asteroid belt. They're going to be in something called the Oort cloud. Is it G, asteroids? That seems like a pretty good answer because Mars is here, which is the fourth rocky planet or inner planet or terrestrial planet, which is separated by the asteroid belt into Jupiter? Is it meteorites? No, meteorite is something that contacts the Earth's surface. Is it satellites? There are a couple different types of satellites. There's natural and there's man-made. We have one natural satellite that is called the Moon. We have many man-made satellites. Some of the famous ones are Hubble Space Telescope, the International Space Station, because these are things that orbit around us and are attracted by our gravitational pull. But again, the best answer here for what is between Jupiter and Mars are asteroids, because the asteroid belt separates the inner and the outer.
Go ahead.
Which image below best represents our galaxy? Is it F? This looks like a spiral galaxy. Is it G? This looks like an elliptical galaxy. H, which could either be an elliptical or a irregular galaxy, or is it J? This is actually a star, so that is not a galaxy. You can tell that it's a star because of all of its pixelated kind of things moving away from it. Just represents overexposure based off of what it actually is. Now this picture over here, I hope we all understand that this is not actually a picture that anyone has ever taken of the Milky Way. We have never been out of our Milky Way. We have sent one space probe or space satellite out of our solar system, and that left back in the early 70s. So in that amount of time, we barely made it away from our little solar system, but the best representation of our galaxy is a spiral galaxy. We live near the Orion Arm. Based on the drawing above, what is the main reason that Venus would appear brighter at point Q rather than at point R as seen from the Earth? Okay, in order to understand what this one is actually asking us, it's telling you why are the sun's rays making it a little bit easier for us to see Venus brighter than we would Venus at Q brighter than what it is at R. At R, only the part of the planet Venus that is being lit up by the sun's rays is basically directly in front of us. We're actually going to be able to view this part of Venus right there. So based off of that, again, looking at this picture, no matter where you are in the solar system, a part of the celestial object that you're on or looking at, 50% of that object is going to be lit up by sunlight, by the rays of the sun. So the planet is closer to the Earth at point Q than at point R. Nope, same distances, so that's not it. Is it G, more of the visible side of the planet is illuminated at point Q than at point R? More of the visible side. Are we able to see that? Is it visible to us? This seems like a pretty decent answer. Let's keep reading on, because you can't ever pick the first one that you think is correct. You have to read all the questions. Is it the planet appears overhead against a dark sky when it is at point Q but not at point R? That really makes no sense, guys. That's just saying that for some reason it's a dark sky at one point but not a dark sky later. Or is it J, light from the planet at point Q is less affected by the sun's gravity than at point R? Light is going to move at its own rate except for at a black hole, and this is not a black hole. So the best answer here is going to be G. What element is the main component of most stars? So as this question is asking, the most abundant and lightest element in the universe is hydrogen. And hydrogen is going to be used from our nebulas over time. When they condense and start spinning, they're going to push down and have gravity is going to force it in, and it's going to cause fusion. So hydrogen is the main and most abundant element to make up stars. Nitrogen, iron, and oxygen, over time when hydrogen turns into helium, helium eventually is going to have to fuse, and over time, depending upon the amount or the mass of the star, is going to depend if they ever get to these other ones. For instance, our star will probably only make it to oxygen before it starts to essentially end its life. In 1912, an astronomer at Arizona's Lowell Observatory noticed that the lines in the spectra of most galaxies shifted towards the red end of the spectrum. Another American astronomer, Edwin Hubble, later interpreted this discovery as evidence that... So, we talked earlier that red shift versus blue shift. If a planet, us, here, is looking at something at one point, which let's say is here, And then over time, it moves away, and we can track to see that the spectra is moving, or what we see from the galaxy is changing. We know that it's moving away. So galaxies were once part of one huge mega galaxy. Nothing up here is talking about that whatsoever. That's a bad answer. An explosion will one day result from the pressure building as the galaxies expand. Does not talk about an explosion up here. Redshift is simply that he is able to interpret that things are moving away. Is it H? Galaxies are moving away from each other in a constantly expanding universe. This sounds very good like an answer, but let's read J. Largest galaxies are slowly engulfing their smaller neighbors. That does not talk about it whatsoever. So again, by it saying that it moves towards the red end of the spectrum, red is actually the longest wavelength, which is why when the sunlight is going into our atmosphere, sometimes it bends as it's going down as it's the sunset, so that's why it's a red sunset. So the best answer here again is that galaxies are moving away from each other. What process has occurred when atoms combine to form a new element and release energy? In astronomy, when atoms combine, they are making more energy through fusion. So fusion is where the most simplest is hydrogen and hydrogen slams together through fusion to make energy, and that energy is seen through stars. On Earth, fusion is what we do at certain power plants to break down large elements. Hydrogenation, hydro is water, ionization, both of these are not pertaining to what we're talking about. Fusion is our best answer. The sun emits energy by converting hydrogen into helium. What is this process called? The process of slamming hydrogen and hydrogen together is called fusion. Fusion is when you take one thing that is small and you slam it with another thing that is small, in this case hydrogen and hydrogen, to create helium. This is called fusion. Fission is when you are breaking down large objects into smaller ones to separate and make energy. Sunspot formation, while this does deal with the sun, sunspots are caused by magnetic disturbances, and solar wind is something that on the outside is being released that essentially makes northern lights or southern lights. When Venus passes between the Earth and the Sun, it is visible as a tiny black dot on the Sun's bright surface. Why is Mars never visible in this same way? Is it F? The orbit of Mars is more eccentric than that of Venus. Eccentricity just basically represents the amount of circle or circular orbit or revolution that is occurring. Is it G? The orbit of Mars is outside that of the Earth's orbit. So Mars is outside of our orbit, so that does sound like a pretty good answer. Let's come back to that one. Mars is too small to be seen against the backdrop of the sun. Mars is not that small, and it is also behind us, so that could be part of the answer. So G is looking pretty good. Or is it J, Mars shines too brightly to be visible against the sun? No, that is not the correct answer. So the orbit of Mars is outside that of the Earth's orbit, and because Mars is outside of our orbit, that means it's out here. We would never see any of Mars's shadow on here. It just wouldn't work. Which of the above evolutionary stages of a massive star is called a supernova? This is your nebula. This is where it is going to all start, gas and dust. A supernova is going to represent the explosion. So in this case, which of the above evolutionary stages of a massive star is called a supernova? Go ahead and just look for after it expands to where it blows up. The blow up is the supernova, and then you have the black hole or the neutron star from a very massive star. And the best answer here is number 4. Which planet rotates the fastest? So again, a rotation represents the amount of time that it takes to spin or rotate once on its axis. The axial tilt is right there. Is it Mercury? You just look up at the chart and you look through to see which one represents the least amount of time. Right here we can see that Jupiter is the least amount of time at 10 hours, which means that the answer is C. Photographs of the surface of Mars reveal the presence of sand dunes that shift over time. These dunes demonstrate the presence of what phenomenon on Mars? So precipitation represents rain, so these are not going to shift because it rains. Winds, that's a pretty good answer. Look, you can see that the winds of this dune are forcing this to move. Magnetic pole reversals is not going to have anything to do with why certain things are moving up on the surface. And plate tectonics. For dunes to move, it's not going to be based off of plate tectonics. The best and most realistic answer is G, wind.